Good morning. Today we are going to be solving absolute value inequalities. So we solve absolute value equations in chapter 1 where we have an equal sign with an absolute value, and we talked about absolute value being measuring distance, correct? And therefore absolute value cannot be negative. So now we're going to have an inequality instead of an equation, but we're still going to have two answers the same way that we had two answers before if we do have a solution. So let's get set up our notes. You should have your ruler. You should have your red pen. You should have your highlighter and your pencil as well. And this will be my pencil, so that way you guys can see a little bit better. Somehow the pencil reflects quite a bit with the projector and the camera. So first, let's go and set up our notes. We know that we have to do 6 spaces, 2, 4, 6. And that's going to give us the ability to be able to organize them a little better. And that way you can write any comments on the left, any questions that you may have. We have 2.4. Even if I cover it too much, I can make myself smaller for now. Great. So 2.4, solving absolute value inequalities. And now you should also have your cutout. The cutout that we're going to be using is this one here. Can you see it? So let's go and place your cutout. We're actually going to have them right next to each other, so you don't need to cut them through. We're actually going to paste the entire thing right here. So you should have a glue stick, or you can tape it if you want, but I prefer if you actually use a glue stick. That way you can actually highlight. You can do it right. Don't do it on your paper again, on your notebook. You know what happened last time. So we're going to glue it, or you can get a separate piece of paper, which I prefer to do. Just scratch paper that you have around. Make sure you get your corners. I'm going to do an X in the middle. And line it up nice and neat. Make sure it's even on both sides. It doesn't have to be perfect, but if it is, I will appreciate it. So therefore, let me move myself to the side. Excellent. So we are going to be covering absolute value inequalities. So an absolute value inequality is an inequality that contains an absolute value expression. Simple enough, right? For example, the absolute value of x is less than 3, and the absolute value of x is greater than 3 are absolute value inequalities. Recall that absolute value of x equal to 3 means that the distance between x and 0 is 3. So therefore, before it used to be the absolute value of x, it was 3. We knew that it was either negative 3 was 3 units, 1, 2, 3, or positive 3, 1, 2, 3. So therefore, there used to be two solutions, correct? But now it says the absolute value of x is less than 3. So let's go and place it 0. It's here. For example, if I say you're going to walk less than 3 units, less than 3 blocks. So we can walk towards the right or towards the left, but it has to be less than. So can it be 1? Yes. Can it be 2? Yes. Can it be 2.5? Yes. But it cannot be 3. So therefore, we're going to leave it as open. Because 3, if there was an equal sign, then we can actually walk 3, right? Now, we're walking less. Distance has to be less than 3 from 0. So therefore, can we walk to the left? Yes. 1. Can we walk to the left? 2. Yes. Can we walk to the left? 3. Yes, but we cannot reach 3. So therefore, because it has to be less than, it can be anything in between. Do you agree? So therefore, every time there's a less than, it should always be crashing against each other. And if it's greater than, that means that the distance has to be greater than 3. Can it be 2? No, it has to be greater than 3. Can it be 1? No, it has to be greater than 3. Can it be 3? No, it has to be greater. It cannot be equal sign. There's no equal sign, so therefore it will be greater. And anything beyond 3 is more than 3 units. Do you agree? Or it can be to the left. And anything beyond negative 3. So therefore, if it's great, if the absolute value of a number of x is greater than 3, has to be an OR. So let's write that down. This will be an OR. And remember that whenever it's connected, say AND. So this will be an AND. And notice that the layout will be the same as before. But now, if it's an absolute value, if it's less than, if it's greater than, oh, there's an error in here. What should this be if it's less than? This one should be an AND. So can we fix that? So therefore, if it's less than, it has this and this. If it's greater than, that'll be an OR. And we're going to write them down the same way. So let's go through the process. Notice that in this case, we're going to highlight the absolute value just like we did before. This will stay the same both times. The only thing that's going to change is the first one is exactly the same. The second one, we're going to flip the inequality, it will be minus. On the second one, the absolute value is going to be twice, once, twice. The first one will stay exactly the same. The second one will be less than. And then we're going to change that. So we're going to flip it and then change it to a negative. Let's go to the first example. And let's go and write small so we can actually fit one next to the other. It's going to take a little effort to write a little smaller, but let's go and try to see if we can fit both next to each other. We have example number 1. And we have solve and graph. A. We have the absolute value of x plus 3 is less than or equal to 2. And B, we have the absolute value of 3x minus 5 is greater than 1. So before we actually start to solve it, we need to be able to decide, is this going to be an AND or an OR? Remember, if it's less than, and let's write that down on the left. If it's less than, think of this as an L. Less than is going to be a AND, land. Greater will be a OR, TOR. I have nothing else. So less than is a land, LAND. Greater than is an OR. So is this, so place your hands like this. Which one's an L? This one here. So that is less than. So therefore this one is an AND. And this one, it's an OR. So AND OR. Repeat after me. AND OR. And OR. So therefore, when we rewrite them, it's going to be the same process. It's going to be x plus 3 the first time. Remember, write small. Is less than or equal to 2. And we're going to highlight what's inside. This stays the same both times. And x plus 3 is greater or equal to negative 2. So that gets flipped. So the first time is exactly the same. The second one, we also have to flip the inequality. Now, we are going to solve the first one. And we're going to solve the second one. So what should be my next step here? So in this case, I need to be able to leave the x by itself. So I need to subtract 3 on both sides, or just move my 3 to the right, becomes a negative 3. That gives me x is less than or equal to negative 1. And we solve for x. Now we're going to do the same thing with the second one. I need to leave the x by itself, so just move the 3 to the right. You can say negative 3. So that gives me x is greater or equal to negative 5. And it's an and. Now, if it was an or, we'll be done. But ands, they need to be connected at the very end. Just like we covered on the last section with compound inequalities. Ands should be connected. So to connect them is a very quick process. Which number is smaller? Negative 5 or negative 1 or negative 5? Negative 5. So negative 5 goes here. The x will go in the middle. And the bigger number, which is negative 1, goes on the right. And now I'm going to copy this down. X is less than or equal to negative 1. So therefore, the greater than is towards that negative 1. So it has to stay the same. Now, when I copy this down, you need to decide, is the greater towards the x or towards the negative 5? Correct. It's towards the x. So therefore, the greater than has to be towards the x. Now let's go and graph it. I just need negative 1 and negative 5. So I'm going to place my 0 over further to the right. Negative 1 will be here, and negative 5, negative 2, negative 3, negative 4, negative 5 will be here. Then I need to decide, is negative 5 open or closed? Correct, that's going to be closed. Is negative 1 open or closed? That's also going to be closed. And automatically they should be crashing against each other. I'm going to highlight my solutions. My solutions will be negative 5. Can I highlight negative 5? Yes. Can I highlight negative 1? Yes. Because of the equal sign underneath, I can actually, both of them are also solutions. All the way from negative 5 all the way to negative 1 in any number in between. So now let's go and try letter B. Letter B, is that an and or an or? Let's see, greater, that's an or. You see it? So therefore, I write down the word or on top. And when we separate them, it's going to be exactly the same. The first one will be, let me write small and make sure that you just make it fit. 3x minus 5 is greater than 1. Easy. And I'm going to highlight what's my absolute value because that part stays exactly the same. That gives me 3x minus 5. And I have to flip the inequality and negative 1. And what should be in between? In between should be an or. And I just solved the first one. I solved the second one. And I'm done. So let's go and solve the first one. I'm going to draw the line. Go and solve it. See what you get for each one. Go and solve the second one. See what you get. Go and pause it. And then we'll continue once you're ready. Got it? Excellent. So let's go and move my 5 to the right. We can say positive 5. That gives me a 3x is greater than 6. And we have divide by 3. Sometimes I'm not sure if I'm looking this way or the other way. So therefore, x is greater than 2. And I'm going to solve the second one. On the second one, I'm going to move my negative 5 to the right. We can say positive 5. That gives me a 3x is less than 4. And I'm going to divide by 3. So that gives me x is less than 3 or 4. Is that an improper fraction? It is. So 3 goes into 4 one time. My denominator stays the same. 1 times 3 is 3. To get to 4, I need 1 more. It'll be 1 and 1/3. And now we can graph it. So you need to be able to know where they're located, correct? We know where 2 is located. Now the question is, do you know where 1 and 1/3 is located? So there's 0, 2 is here. Where is 1 and 1/3? What's 1 here? And then we're going to divide this in 3 sections by placing 2 dashes. So it's 1/3, 2/3, and 3/3. So it's right here, the first third. So it'll be 4/3. It's going to be open on both. Do you agree? And in this case, all the numbers that are greater than 2 are to the right. And all the numbers that are less than 1 and 1/3 are to the left. And remember that because there's an or in between, they should be going away from each other, and they are. And this one's open, even though it looks like to be closed, that's an open. So let me go and fix it. So it's open because there's no equal sign underneath. That means that 4/3 is not part of the solution. 2 is not part of the solution. 3 is, 1 is, 0 is, but 4/3, so do not highlight 4/3. Anything to the left and anything to the right, but do not highlight 2 because 2 is not part of the solution. Where over here, -1 was part of the solution, and that's what we place as closed. And -5 is part of the solution because we place it as closed because of the equal sign. In this case, both numbers are not because there's no equal sign on either one. So let's continue. We have example number 2, then example number 3, and then we'll be done for the day. Let's go and place 6. I want to place 6, actually 6, because I do need this extra space today. So I'm going to place my line through. And example number 3. If you need more time, just go and pause it. Solve and graph. So we're going to solve it and we're going to graph it as well. And we have A and B. Absolute value of x is greater or equal to 4, and B will be the absolute value of x minus 8 is less than 5. If you need more time, go and pause it, and we'll start once you are ready. Got it? So in this case, first I need to decide, is this an and or an or? What do you think? So let's see. Let's go and write down on the left. Less than or greater than. So place your hands like this. Which one forms an L? Or for my side? That one forms an L. So therefore, that one is an and, less than, and this one is like a T-tor, greater. So in this case, this one is an and or an or. That is an or. You need to memorize that for the test. And this was less than land, that's an and. So therefore, when I graph this, should be going away from each other. And when I graph an and, should be crashing. So let's go solve the first one. Remember that we're going to have two inequalities. And I'm going to highlight what's inside, which is an x. That means that the first one will be exactly the same. X is greater or equal to 4. And the second one will be x. And you need to do two things. You need to flip the inequality. And that becomes a -4. And now we solve each one separately. Oh, but they're solved. They're done. Easy as that. So the first one is solved. The second one is solved. And what should be in between? An or. And now let me go ahead and graph it. So take the time to graph it. Go ahead and pause it. See what you get. And then we can compare our answers afterwards. We have 0 in between. We have +4 on the right, 2, 4. -4 on the left, 2, 4. And let's see, open or closed? So this one should be closed. And on that one should be close as well. And because it's an OR, automatically they should be going away from each other, correct? They are avoiding each other. Notice that this is x is greater than 4 to the right, x is less than negative 4 to the left. So ands, ORs, let's try letter B, or try by yourselves and see what you get. Go ahead and highlight what's inside the absolute value. That will remind you of two things. The first one, that you have two answers, and the second one is that that always stays the same both times. Go and pause it. Got it? So in this case, I'm not going to write in the first one exactly the same, so therefore that'll be x minus 8. And I'll write in the second one, x minus 8, but two things I need to change, the inequality, and the 5 becomes a negative 5. And now we can solve it separately. I'm going to solve the first one, and I'm going to solve the second one. The first one, I'm going to move my 8 to the right, we can say positive 8. So therefore, I need a 13. X is less than 13. The second one is going to be move the 8 to the right, we can say positive 8. So that'll be just positive 3. Or an equal sign, you say greater than. So just be careful. We're so used to just writing down equal signs, right? So therefore, I'm not going to place my number line. I need 13 spaces, but I don't need any negative numbers. Oh, what happened here? And I was using the ruler. Imagine. I'll just leave that as that. So therefore, let's say 0 is here. 1, 2, 3 is here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I need to decide, is it going to be open or close? Open, and on that one will be open as well. And all the numbers that are less than 13 are to the left. All the numbers that are greater than 3 are to the right. And yeah, they should be crashing against each other. Let me go and highlight what's the answers. Can I highlight the 3? No. Can I highlight the 13? No, because they're not part of the solutions. So therefore, that will be my answer. But remember, we have one more thing to do. Do you remember what we need to do before we actually finish letter B? Correct. Every time you have an and, you have to connect them. And to connect them is a very easy process. The x goes in the middle every single time. The smaller number will go on the left, so therefore smaller number is 3. The bigger number is on the right. And in this case, x is less than 13. The greater is towards the 13. In this case, the greater is towards the x, not the 3. And the last example for today. So let's go and make a line. Let's make it all the way through. See if I can make a straight line this time around. Example number 4, A and B. So we're going to do A first and then B. That's going to take a little bit more space. That's example number. So this was example number 2, and this was example number 3. You probably noticed that before I did. So let's go and solve and graph it. A. We have the absolute value of x minus 5 minus 7 is less than 4. So before we actually start to solve it, or before, you should notice that there's an absolute value, and we're going to highlight. But before we actually separate into two different inequalities, we need to make sure that we leave the absolute value by itself. So therefore, I need to get rid of the negative 7. Same thing that we covered on the last section. When we had an equal sign, remember, we did the same thing, that we cannot divide into two different inequalities until we get rid of the negative 7. So how can I do that? Move my negative 7 to the right, we can say positive 7. And now we have the absolute value of x minus 5 on the left is less than 11. And now that we have the absolute value by itself, now I can separate into two different inequalities. The first one will stay the same. The second one, remember, two things I need to change. That becomes a greater than, and that becomes a negative 11. And now we can solve each one separately. But before you start solving, is this an and or an or? Correct, it's an and. So that forms a less than L. So that's an and. Let's go and solve each one separately, graph it, and see what you get. Got it? So in this case, move my negative 5 to the right, becomes a positive 5. That gives me x is less than 16. The second one, move my negative 5 to the right, becomes a positive 5. So therefore we have x is greater than negative 6. And now I'm going to graph it. So I need a bigger line. Now sometimes if the numbers are that large, you can do it by 2. So I prefer if you don't, but I know that sometimes they might get a little larger than it might fit on paper. So let's go and place 0 here. Let's count by 2. Negative 2, negative 4, negative 6. Then 2, 4, 6, 8, 10, 12, 14, 16. And that might help out with the spacing, correct? So therefore, I need to decide, open or close. On the 16, it's going to be open. And on the negative 6, it's going to be open as well. And remember, it's an and, so they should be crashing. So if you know it's an and, we can just connect them, and that's it. Or if you want, you can graph each one separately. But also, if we know it's an and, we know that we need to connect our answers afterwards. So therefore, that'll be, let me place a randomly, it's fine. We have x in the middle. Negative 6 is the smaller number, that'll be on the left. Bigger number goes on the right. And the greater is towards the 16, so this one stays the same. The greater is towards the 16. But on this case, the greater is towards the x. So therefore, I need to make sure that it's towards the x still. Therefore, that is my answer. So you'll see it connected as your answer. And you know that your ands are also connected. And you should be able to bring it from those two expressions into one by placing the smaller one on the left and then the bigger one on the right. B, last example for today. On letter B, we have the absolute value of 2x plus 1 plus 2 is greater or equal to 7. Go ahead and pause it, solve it, decide if it's an and or an or, graph it, and see what you get. You got it? So what should be the first thing that I should do? Correct. Highlight my absolute value. And we need to be able to leave the absolute value by itself before we separate the two equations. So therefore, I should move my 2 to the right. You can say negative 2. So now I have the absolute value of 2x plus 1 is greater or equal to 5. And now that I have my absolute value by itself, now I can separate into two different inequalities. The first one will stay the same. The second one, there's two things I need to change, 1 and 2. So therefore, will be 2x plus 1 once again. I have to flip the inequality, reverse it, and then negative 5. So remember that there are two things to change on this side. And now we can just solve each one separately. Draw the line and draw the line. Move the 1 to the right, becomes a negative 1. That gives me 2x is greater or equal to 4. And now we can divide by 2. Divide by 2. The 2's cancel, so therefore x is greater or equal to positive 2. On the second one, leave the x by itself, so let's get rid of the 1. You can do minus 1 on both sides, so I can just move my 1 to the right, becomes a negative 1. That gives me 2x is less than or equal to negative 6. And the last step will be to divide by 2. My 2's cancel, so therefore x is less than or equal to negative 3. Do I need to flip the inequality? No. Only way, doesn't matter whether your answer is positive or negative. What matters is whenever you have a negative 2x, then you'll need to divide by a negative number. But if your answer is negative, it doesn't matter. You don't need to flip the inequality if you did not divide by negative. In this case, I only divide by positive 2. And is this an AND or an OR? Yeah, this one is an OR. So therefore, the only thing I need to write down an OR, I do not need to rewrite it like this. And the only thing I need to do last is to graph it. Let's go and graph it, make a nice number line. I want to place my 0 in the middle, my 2 on the right, my negative 3 on the left. And automatically, because it's an OR, they should be going away from each other, correct? X is greater than 2, open or close? Open or close to the right. Open or close? Negative 3. All the numbers that are less are to the left. So this will conclude the lesson for today. Please email me if you have any questions, and I'll see you guys next time.